That's the maximum takeoff weight of the largest aircraft ever built. To put that in perspective, it's heavier than 10 fully loaded Boeing 747s. A wing as long as a football field, 6 engines producing over 100 tons of thrust, and a cargo bay that once held 5 battle tanks simultaneously. This is the Antonov AN-225, born in secrecy behind the Iron Curtain during the Cold War. Built for one purpose, to carry the Soviet space shuttle. Abandoned and left to rot when the USSR collapsed, then resurrected to become the world's most legendary cargo aircraft. But here's what most people don't know. How does 800 tons of metal, fuel, and cargo even leave the ground? What engineering secrets allow it to defy the laws of physics? And what happens inside the cockpit when only a handful of pilots in the world are qualified to fly it? Today, you're going inside the world's largest aircraft, and you're about to discover the 7 engineering marvels that make the impossible possible. Let's begin. The AN-225's cargo bay is 43 meters long and 6 meters wide. That's longer than the Wright brothers' entire first powered flight. But the real engineering genius isn't the size, it's how you get cargo inside. The nose of the aircraft is fully hinged. Precision hydraulics lift it upward like a giant mouth, providing open access to the entire cargo bay, but it sits too high off the ground to load directly. So the aircraft does something extraordinary. The front landing gear pylons are jointed. The fuselage lowers itself, bowing down like a giant snake, unlatching its jaw to consume its prey. A ramp unfolds. An 11-person ground crew positions the cargo. Then the aircraft lifts back up, seals the nose, and prepares for flight. For the loadmaster supervising this operation, precision is everything. A single miscalculation, cargo positioned even a meter off-center, could shift the aircraft's center of gravity. And at 800 tons, there's no room for error. In May 2016, the AN-225 transported a 117-ton industrial generator from Prague to Perth, Australia. That's the equivalent weight of 18 African elephants. The generator had to be winched into position with millimeter accuracy. This loading system is why the AN-225 is the only aircraft in the world capable of transporting cargo over 100 tons. No other plane can even attempt what it does routinely. And when the nose seals shut, that's when the real engineering challenge begins. Because carrying weight is one thing, flying with it is another. The wingspan of the AN-225 is 88 meters. If you parked it in a football stadium, the wings would stretch beyond both touchlines. But here's where the engineering gets fascinating. On civilian aircraft, wings are mounted low and angled upward. This helps the plane naturally stabilize itself in turbulence. But on the AN-225, the wings slope downward instead. Why? Because when carrying extremely heavy loads, the wings flex upward during flight as lift is generated. The downward angle compensates for this natural deflection. The wings were over-engineered from the beginning, designed to carry not just cargo, but an entire space shuttle mounted on top. At the wing roots, massive reinforcement beams distribute the load and prevent the wings from tearing away from the fuselage. For the Ukrainian engineers who designed this system in the 1980s, the pressure was immense. Everything was top secret. No one outside the program knew what they were building, and they were designing the most complicated wing structure ever attempted. One engineer later recalled, "Everyone was extremely excited. All knowledge and abilities were dedicated to finding the best possible solution." When the aircraft made its first flight, tension was high. It was far larger than anything that had flown before. Then it lifted off. Seeing it lift off smoothly, gracefully, and slowly was an indescribable feeling, one designer said. For us, it was a moment of triumph. This wing design is why the AN-225 once set a world record by carrying 5 battle tanks, over 300 tons of cargo, in a single flight. These loads were even heavier than the Soviet space shuttle it was originally designed to transport. But wings alone can't keep 800 tons in the air. For that, you need raw power. The AN-225 is powered by 6 massive turbofan engines. Each one produces 24 tons of thrust during takeoff. Together, they generate more than 100 tons of thrust. But power comes at a cost. The aircraft burns approximately 15 tons of fuel per hour. That's why it makes strategic refueling stops in countries where aviation fuel is cheaper. On the Prague to Perth journey, the AN-225 couldn't fly direct. It had to plan multiple layovers purely for fuel economics. Hiring the AN-225 costs approximately $30,000 per hour, with a total flight. Time of dozens of hours for long-haul cargo missions. Operating costs skyrocket into the millions. For the flight engineer monitoring engine performance, every gauge matters. 6 engines mean 6 potential failure points. Fuel flow, temperature, thrust output, all must be balanced perfectly. One engine producing even slightly less power than the others could create asymmetric thrust at takeoff. And with 800 tons trying to leave the ground, asymmetry is catastrophic. Operational reality. This fuel consumption is why only the most critical cargo justifies using the AN-225. The generator it carried to Perth weighed 117 tons. Transporting it by air was extremely expensive. But when ground or sea transport would take weeks and downtime costs millions, $30,000 per hour suddenly becomes worth it. But even with perfect engines and perfect wings, you still need a way to control 800 tons moving through the sky. And that's where the next marvel comes in. Technical impact. The AN-225 doesn't use traditional mechanical linkages to control its flight surfaces. Instead, it uses an electronic fly-by-wire system. When the pilot moves the control stick, computers process the input and command hydraulic actuators to move the enormous control surfaces. The aircraft has 4 independent hydraulic systems. If one fails, the others can maintain control. This redundancy is critical. A control surface failure on an 800-ton aircraft at altitude is a death sentence without backup systems. For the pilot flying the AN-225, trust in the fly-by-wire system is absolute. There's no direct physical connection between the cockpit controls and the rudder, ailerons, or elevators. Everything is mediated by computers. Only a very small number of pilots are qualified to fly this aircraft. They undergo years of specialized training, and when they pull back on the stick during takeoff, they're not just trusting the hydraulics, they're trusting decades of Soviet-era engineering to interpret their inputs correctly. This fly-by-wire system is what allows a crew of just a few people to control a machine the size of a city block. Without it, the control forces required to move the flight surfaces would be physically impossible for a human pilot to generate. But all the control in the world doesn't matter if you can't safely land. And landing 800 tons is where physics becomes truly punishing. Technical impact. The AN-225 is equipped with 32 wheels. They distribute the immense weight during touchdown. Each wheel is mounted on a special oil and gas shock absorber. When the aircraft touches down, the tires heat up dramatically. They're filled with nitrogen instead of air, reducing the risk of explosion from heat buildup. The tires must be replaced every 90 landings. Each tire costs approximately $1,000. Do the math. 32 wheels replaced every 90 flights at $1,000 each. That's $32,000 in tire costs alone for every 90 operational cycles. For the pilot on final approach, landing is the most dangerous phase of the flight. You're descending with 800 tons of momentum. The margin for error is razor thin. Too steep an angle, and the landing gear could buckle. Too shallow, and you overshoot the runway. In Perth, after the Prague to Perth journey, tens of thousands of people gathered to witness the landing. The AN-225 had become a spectator sport. People come to watch it take off and land. The touchdown was flawless. This landing gear system is why the AN-225 can operate from airports not specifically designed for super heavy aircraft. By distributing weight across 32 contact points, ground pressure per wheel is reduced. Without this, the AN-225 would punch through most runway surfaces like a hammer through glass. But even with perfect landing gear, there's one engineering challenge that almost ended this aircraft before it ever flew commercially. And it's the reason the AN-225 spent years abandoned in a hangar. The Cold War. The AN-225 was not originally designed for commercial use. It was developed in the 1980s at the height of the Cold War. The Soviet Union had launched a space shuttle program to rival the United States. The shuttle, called Buran, was far too large to fit inside any existing aircraft. So Ukraine's finest engineers were called upon to build the impossible. The result was the AN-225, nicknamed Mriya, Ukrainian for dream. When unveiled at the 1989 Paris Air Show, it captured all the attention. But when the Cold War ended, the Soviet space program was cancelled. The aircraft was left to deteriorate in a hangar for years. There was a real possibility it would never fly again. Then, in 2001, a new opportunity emerged. Around $20 million was spent refurbishing the aircraft. It was converted into a civilian cargo plane. The floor was reinforced, cargo securing. Chains were installed to prevent movement during flight. A winch system was added to allow virtually any cargo to be pulled inside. For the engineers who returned to the hangar in 2001, seeing their creation abandoned was heartbreaking. They had poured years of their lives into building something unprecedented, and it had been left to rust. But the refurbishment gave the AN-225 a second life. It went from Cold War relic to global aviation icon. This resurrection is why the AN-225 has set more than 200 world records. It has a huge global following. It became the only aircraft capable of transporting emergency relief supplies, industrial equipment, and military hardware that no other plane could lift. But all of this, every engineering marvel, every world record, every resurrection, comes down to one moment. The moment when 800 tons leaves the ground. Though with a maximum takeoff weight of 800 tons, the AN-225 appears to defy science. It even dwarfs a Boeing 747. Its 84-meter fuselage would stretch from one penalty box to the other in a football stadium. On the Prague to Perth journey, the aircraft carried 117 tons of cargo. Add fuel, 15 tons per hour for a multi-day journey, and the total weight approached the 800-ton limit. The question every aviation engineer asks, how does this thing fly? The answer lies in the perfect convergence of every system. Wings designed to flex and distribute load. 6 engines generating 100+ tons of thrust, fly-by-wire precision control, reinforced wing roots preventing structural failure, all working in perfect harmony. For the pilot at the controls during takeoff, the sensation is surreal. The aircraft accelerates slowly. The nose lifts. And then, despite every instinct screaming that something this heavy shouldn't fly, it leaves the ground. One witness at the 1989 Paris Air Show described it. Seeing it lift off smoothly, gracefully, and slowly was an indescribable feeling. Public interest in the AN-225 is so high that German news crews filmed every step of the Prague to Perth journey. Watching this aircraft take off is almost a spectator sport. This is the ultimate proof of human engineering. An aircraft born behind the Iron Curtain, built in secrecy, abandoned, resurrected, and transformed into the most capable cargo aircraft ever to fly. By examining it piece by piece, we've discovered how it defies gravity and carries cargo no other aircraft can lift. The Antonov AN-225 is a unique aircraft. It shocked the world with its immense size and unmatched capabilities. What this means for you. Engineering lesson number 1. Over-engineering isn't waste. It's future-proofing. The wings designed for a space shuttle could later carry 300 tons of battle tanks. Engineering lesson number 2. Redundancy saves lives. 4 independent hydraulic systems mean one failure doesn't end in disaster. Engineering lesson number 3. Resurrection is possible. $20 million in vision transformed an abandoned relic into a global icon. The real cliffhanger. The generator reached Perth just one day late. The crew was exhausted but proud. But here's what no one talks about. In 2022, the AN-225 was destroyed during the Russian invasion of Ukraine. The world's largest aircraft, the only one of its kind, was lost forever. Or was it? Because buried in Antonov's archives are the original blueprints. And there's a second AN-225 fuselage, 70% complete, still sitting in a hangar in Ukraine. The question isn't whether we can rebuild the world's largest aircraft. The question is whether we will, and what secrets those engineers will add the second time around.